Hello everyone, this is Dr. Sharif, and today within this video we'll be learning how to get the reaction in this frame where we have a frame A, D, C, B. At A you have a pin support, so at A we should have two reactions, which is Y at A, and then we have X at A. As assumed, X going to the left side because the load is going to the right side, so it's more expected that the X will be going to the left side. Also at support B, it is a pin support, so we'll have two reactions. Again, it will be Y at B and then X at B. There is an intermediate hinge at D, so we can take a moment at D for the bottom side or for the right side and say it is 0, and this will help us also to get the reaction. So always my advice for you is to use this intermediate hinge whenever you have it to get the reactions. But before doing that, let's get also the resultant of the forces. So the resultant of this 20 kilonewton will be exactly at the middle here. 20 times 5 equals 100 kilonewton, and the distance here will be exactly at the middle, so 2.5 here and 2.5 in the other side. Again, also this is 8 times 6 equals 48 at also the middle, so this is 48 at the middle, and the distance here will be as 3 meters, and also from the top 3 meters. If this is 3 meters and this is 4 meters, so this distance here will be 1 meter. We will need also this distance to get the reactions. So we found that we have 4 unknowns: YA, XA, YB, and X at B. Forces, we have resultant of two forces, 140, and distances are given as we can see here. So let's start by choosing which equation we use. If we use summation of force in y direction equal to 0, you have two unknowns, YA and YB, and I don't prefer to start with two unknowns. If we started with summation of x equal to 0, again you have XA and XB, and again these are two unknowns. So what else we can do? Let's use the intermediate hinge. If we take the moment at D for the bottom part, this YA will be eliminated because it's the same line of D. We have only the X at A will be the only remaining, so we can just directly get the X at A. Once you get the X at A, you can take summation of force in X to get the X at B. Then we can take a moment at the hinge for the right part. X is known, you can get the Y, and summation of force in Y, you get the other one. So think about the problem before starting solving to see how you will do that. So as we discussed now, let's start by taking summation of moment at D, but for the bottom part, okay, equal to 0. It means we will take a moment here for this bottom part. In this case, we have how many forces? We have X at A, and we have, this is 48. So taking a moment here, this one will be minus 48 times 3, because this is opposite to what we assumed, okay, plus XA times, this is 6 meters, equals to 0. And from here we can get the XA equals 48 times 3 divided by 6. So 48 times 3 divided by 6, so it will be 24 kilonewton. This is 24 kilonewton going to the left as we assume. This will be our first unknown, which is the X at A. It is 24 kilonewton. This is X at A. Now, once we get the X at A, we can get summation of Fx equals to 0, and therefore we have 48 kilonewton, which is this one, minus 24 minus x at b equal to 0. So minus 24 minus x at b equal to 0. And from here we can get x at b equals 48 minus 24. It will be 24 kilonewton going also to the left side as we assumed. And this will be our second force, which is 24 kilonewton. So we got two forces, 24 and 24, this one and this one. Now we need to get the YB and YA. For the easiest way to get the YB is to take a moment here for that part. How many forces we have? We have 100 multiplied by 2.5. We have the XA multiplied by this 4. We have the YB multiplied by the 5. So 3 forces multiplied by 3 distances. The only unknown, it will be YB, and we'll be able to get it. Let's do that. So taking a moment at D, but for right part equals to 0. Let's assume again clockwise is positive. Then 100 times 2.5, which is this one, 100 times 2.5, plus 24 times 4 meters. So plus 24 times 4 minus minus YB times this distance, which is 5 meters, all equal to 0. From here we can get the YB. Let's use our calculator. So 100 times 2.5 plus 24 times 4, all divided by 5. It will be 69.2. Let me check again. 100 times 2.5 plus 24 times 4, all divided by 5. So it is correct. This is 69.2 kilonewton going up, and this will be our third force or reaction. This is 69.2 kilonewton, and this will be our third. Now it is easy to find the last Y force, summation of Fy equal to 0, then Ya, which is unknown. Now minus 100 plus YB 69.2 equal to 0. From here we can get the YB equals to how much? It will be 100 minus 69.2, so it will be 30.8 kilonewton, 30.8 kilonewton going up, and this will be our third or fourth unknown. It is 30.8, and it is going upward. So we got the 4 reactions, but we cannot be sure about this before we make a check. Check is very important. Again, we have to do it. So we can take a moment at any point that we never used before. We can take a moment at A equal to 0 here using all forces, or take a moment at B for the whole structure. It's up to you. Let's take a moment at A. So summation of M at A equal to 0, and clockwise assumed positive. Therefore, X and Y here will be eliminated because taking at A. So the first force it will be 48 times 3 meters, then 100 times 2.5 meters. Okay, let's do that. So 48 times 3 plus 100 times 2.5. Now this force, 48, 24, and 69 are working counterclockwise, so it is opposite to what we assumed here. It will be negative, both of them. So it will be minus 24, which is the horizontal force, times how much is the distance? It will be this distance here. It is 6 minus 4, so it is 2 meters. So 24 times 2 meters, okay, minus 69.2 times 5 meters, all of that. Let's check. If it is 0, it means we are correct. If it is not 0, it means there is something wrong, and we have to find it. So 48 times 3 plus 100 times 2.5 minus 24 times 2 minus 69.2 times 5, and the result is, as we expected, equal to 0. It means our solution is correct. I hope that this is useful for you. Thank you for watching and see you in another video.